All right, good morning, everybody. We're going to talk about square roots a little bit here today. They go along with exponents, and we'll talk more about the relationship between exponents and uh, radicals. We call these radicals. This is also called the square root. What I see here is called the square root of 9, right? But sometimes we have different indexes, they're called. So you can have like the third root or fourth root or fifth root. We can change the roots, which is why we call them radicals instead of square roots all the time. But we're really typically going to just deal with square roots in this class. Square roots ask, hey, what number can I multiply um, by itself to get what's under my radical here, what's under my square root? That's what the square root's asking. So just like exponents say, hey, 4 squared means 4 times 4, or 16. Square roots do the opposite. They say, hey, the square root of 16, what would I have to multiply by itself to get 16? Well, 4. Okay. So these have kind of this inverse relationship. They back each other up, right? And so what's going on here is we can look through and we can say, well, what's the square root of 9? What number could I multiply by itself to get to 9? But we know that, right? We can say, hey, what about the square root of, if I have 3 times 3, this matches. These are the same thing. So the square root of 9 is actually 3. Okay. So we can do this and we can check for these things and we can kind of guess or check our way there. Or our calculators even have a square root button, right? And if you punch the square root of 9 into your calculator, you'd get out 3 and we'd be in great shape. But what we're going to do today is we're going to look at problems like this, because if you try and put the square root of 12 in your calculator, I can even do it quick. This is the square root. The square root of 12. Let me put this up. Square root of 12. Looks like this. That's not very nice. Yeah, nice. That's not very nice. We don't want 3.464. That's gross. It's hard to do math with, and visually not terribly appealing. Plus, it's not very exact either. Right? So we need a way to talk about it exactly, but we also want to simplify it down a little bit, so it's not just some big number in there. Okay? So what we can do is we can break it into its parts and we can look for pairs. Just like here we had these two were pairs that matched up, and that's why we got out of here. We're going to look for some of those ourselves too. So the plan is to take this 12 down to what's called its prime factorization. Okay, it's a little jargon for you, so it doesn't matter what you call it, but we're going to get it down so it has only prime numbers, only things that can't be divided anymore. So I'm just going to keep dividing by 12 by stuff until I can't divide them anymore. So let's pick some things that we can divide 12 by. We're going to make a little triangle here, or at least a little caret symbol. We're going to break 12 into two things. What multiplies to be 12? We could pick 4 and 3. We could pick 2 and 6. It doesn't matter which order we pick or what numbers you go. We should end up with the same stuff at the end. So I'll just pick, let's say, 2 and 6. 2 times 6 is 12. When you break something down, I suggest crossing it off so you know that you don't use it again. All right, so we did that. Now we got to go look at our 2. Can I break 2 down? Well, the only thing I could do to a 2 is break it down to like 2 and 1, but that doesn't really help. This is useless because we just keep breaking that 2 and 2 down. So no, we can't actually, and that's good. This is the plan. This is what we're looking for. We're looking for numbers like 2 because 2 is prime. 2 can't be divided by anything but 1 in itself. So 2 is good. We're good there. But can I divide 6 by something? Yeah, I can keep dividing 6. It's not prime. I can divide through that. So I can take this 6 down into 3 times 2. Used it, so cross it off. Now try again. That 2 that's there, we already know that that's prime. We just checked. All 2's are going to be prime. And 3, let me think. I can't divide 3 by anything other than 3 in itself either. 3 is prime as well. Okay, cool. So every number at the bottom row here now, this 2, this 3, this 2, all of these are prime numbers. We can't divide them anymore. So now we're ready to write our simplified version. Okay. Our final answer is going to have some stuff out front and then a square root and then some stuff inside. Okay. So we need to decide what goes outside my square root and what stays inside my square root. Okay. To get out of a square root, much like we had 2 3's here, we're going to be looking for pairs of numbers. Square roots talk about one number being multiplied by itself twice, so we're looking for pairs of numbers. So I look at my bottom row of all of these numbers that I grabbed. Is there anything that's a pair? Is there a partner for any of these numbers? Well, this 2 is the same number as this 2. They don't need to be next to each other at all. They just need to be in my bottom row somewhere. So these 2's together are going to partner up. And if they have a pair, if they have a partner, they become, they break out of jail together, kind of, right? So they're going to leave, and both of these 2's get used up, and 1 2 comes out front. 1 2 comes out front. Okay. So they're both used. Are there any other pairs? Well, the only thing that's left is this 3, and he doesn't have any pairs left. So anything that doesn't have a pair gets put back in my square root and left inside. Okay. So this 3 here, box, this is what comes back inside. So my final answer for this, the square root of 12 is equal to 2 times the square root of 3. And that's going to be the whole process for today. Okay, so let's buzz through a couple more of those. This is our general shape of it. We're breaking it down to its prime factorization till everything can't break down any further. We're going to find some pairs. Pairs go together and come out front. Leftovers stay inside my square root. Okay. So what's that look like? Well, you can once again break them down however you want. 60. What goes into 60? I don't know. There's a lot of stuff. 2's and 4's and 6's and 10's, and pick whatever you want. It doesn't matter what numbers you pick. I'll pick 6 and 10. Boom, cross out once you use it. All right. We're going to break 6 into 6 breaks into 2 times 3. 10 breaks into 2 times 5. Just it up, cross it off. And now I have a 2 that's prime, can't break down. 3 that's prime, can't break down. 2 that's prime, can't break down. And 5 that's prime, it can't break down. Okay, nice. So we have our stuff. So now we're going to say, hey, what comes out front? What are some pairs? And what's left over inside? What doesn't have pairs? What doesn't have a friend to get out of jail with? Well, if we look here, we'll notice that I have a pair of 2's again. Hey, here's a 2, and here's a 2. Together, they group together, and 1 2 gets to come out front. We use both of them up, and 1 2 shows up. Okay. Are there any more pairs? Well, what I have left is a 3 and a 5. Those aren't pairs. They're not the same number. They don't have a pair. There's not a second 3 I can grab together, so we don't have any more pairs. We're going to take all the leftovers that don't have any pairs to go with, and those come back. This 3 here and this 5 here, both going to come back in 3 and 5. And what do we do with those numbers when we have multiple either out front or multiple inside still? Well, we're going to multiply them together. So we're not just going to put 3 5 here. We're going to put 3 times 5, and we'll actually multiply those back together. So if you have multiple things that come out front or multiple things that stay inside, we're actually going to multiply them back together. Our best answer here is 2 root 15, because 3 times 5 is 15. So any leftovers that you have or multiple things that either made it out or stayed in need to be multiplied back together. Okay. Cool. Let's try again. 56. Break it down by some stuff. I think 56 has a bunch of different things you can multiply it through. I notice, 8 and 7? 8 times 7. Okay, cool. I use 56, so we're crossing it out. 8 breaks down. That's 4 times 2. Cross it out because I used it. 7. The 7 break? 7 is prime. Okay, so 7 can't break down, and that's okay. So we're going to use the 7. He's going to stay kind of high this time, so don't forget about that number there. But we will use that 7 later. Okay? So 4 breaks down. This is 2 times 2. Cross. But now I have 2, 2, 2, all of which are prime, and a 7, which is a prime as well. So we're down to everything. We broke it all the way down. Use your calculator. Just pop and keep dividing by stuff until you find out what works. Get down to numbers like 2 and 3 and 5 and 7. So what comes out and what stays in? Well, we're looking for pairs. I have a pair of 2's here. Here's 1, 2. Here's the second 2. They are a pair of 2's. I notice that there's a third 2. We can't just grab all of the 2's. They need to be in pairs. They need to be 2 2's or 2 3's or 2 5's, right? So we can't use all 3 of these 2's. We're grabbing 2 at a time. Pairs, 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 pairs. So we're going to grab these 2's. They come together. We use them up. And it comes out front. Are there any pairs left? What I'm left with is a 2 here. Yes, we had 2's before, but we don't anymore. And I have a 7 here that doesn't have a pair as well. These are the numbers that go inside. So it's okay for some numbers to pair up and like still have an extra of that same number, but we can only grab 2 of them at a time. You can't grab 3 at a time or anything like that. Okay. So we still need to bring these guys in 2 times 7. Or the prime factorization of all this, or excuse me, our simplified radical is going to be 2 root. That's our final answer there. Okay, so make sure you're multiplying any leftovers back together and slapping them inside that square root. Cool? Okay. Last one. It's a big boy. We'll break it down. Break down 300. This is 3 and 100. There's a bunch of different things you could use. 30 and 10. You could use, I don't know, I'm sure a bunch of other stuff. Once again, it doesn't matter what order you break it all down in, it'll still work. Just be careful. Okay, 100 breaks down into, I don't know, let's do 10 and 10, why not? 10 and 10, okay, cool. Oh, that 3 can't break down, right? We're like 3 is they're done for. But 10 can keep going, 10 is 5 and 2. Okay. Oh, and this 10 is 5 and 2 as well. Okay. So now I have a 3, a 5, a 2, a 5, and a 2. All of these values are prime. We did it. We're done. It's beautiful. Find your pairs. What are some pairs here? Well, I have 5 and a 5. They pair up and go outside. You don't have to put this on there. I was just visually doing that. So 5 comes out front. Any other pairs? Well, yeah. Hey, look at this. There's a 2's as well. I got a 2 and a 2. Here's pairs. Boom, boom. So a 2 is going to come out front as well. Both of those things come out front. We'll multiply them together at the end. Okay, both of them come out front. And what's left over? Oh, well, this 3 is left over. Don't forget, sometimes you break something down early and it's prime and we kind of drop it. So if this was a little higher, you got to look up still and make sure you use everything. That's why I like crossing stuff off so that you know if you used it or not, right? Because we don't want to come back and use this 10, but we do need to make sure we come back and use this 3 because that 3 was prime and didn't get used up. So that 3 is what stays in my square root. Boom, multiply any in the front or in the inside together. This is 10. Okay, and that's what I'm going to have you practice today. So today, when you go to do these, you have about 10 of these problems to do. Break them down, show the work of breaking them down. So I know that you're doing these. Break them down. It shouldn't take terribly long, and I know some people finished our exponent stuff in class yesterday. So there shouldn't be that much to do today and tomorrow. Please make sure you have both the problems on of the exponent work with the product rule and the power rule that we went over yesterday. So yesterday's assignment, it's like 18 problems, but they go pretty quick. So try those problems if you didn't finish them yesterday. And then There's a new assignment. That's 10 problems today, 10 of these guys where we break them down and find the simplified version. Okay. Do your best on these. We'll answer some questions and ask some questions about them on Thursday in class. But this assignment, along with what we did yesterday, are the two things that you need to have turned in by class on Thursday. Please make sure that you're productive today or tomorrow so that we can keep cruising. Okay. All right. Thanks, ladies and gentlemen. Have a great day. See you on Thursday.